Okay, so let's get right into it. So before in Jason's session, he talked about what Jaseci, what Jack is, how to set up Jack, uh, and how to let your coding agent learn how to code in Jack using the Jack MCP server. So I'm not gonna go through those information again. Uh, but like those are available in the announcement channel as well. I think we sent out all links that will help you guys. So in this session, we're gonna focus more on how to build agentic applications using the features in Jack language. One thing is the ByLLM feature or the ByLLM language abstraction, as well as the object spatial programming abstraction, which is basically the graph where you can build graphs, you can run workers on the graph. So we are using that to build agents in this tutorial, so you can leverage these in your in the projects that you're going to work on just 24 hours. Cool. So the first question that I have is, what is an AI agent? Anyone like to just yell out what an AI agent is? No one? Go on. Okay. Okay. That's an to be honest, there's no technical definition of what agentic AI or AI agents is, but your definition is valid, is where you give it a persona to do a task using some tools it has. Okay, no.
A specific set of skills.
And that's another definition, I think more inspired with like OpenClaw kind of vibe. They have a bunch of skills, that skill.md files that you can create and also download and just give it to Claw, and it will understand how to do different workflows. And when we think about agentic AI, it's a kind of a buzzword rather than a actual thing. Agentic AI agent, we can define it like that. Agentic AI is when we feel it's hard to define. The way I define it, a program that exhibits agency is AI agent is agentic, and agentic AI is a bunch of AI agents. So that's my definition, but that changed from person to company to whatever. So the key challenges that we face when we build these applications, it's not about we see that there exist applications out there. So how are these built and what are the challenges? So that's our question. It's not about, there are AI agents, how to use them. That's great. That's basically using Cloud Code. But how are these agents built? What are the primitives inside there? So when we think about this and go and look at open source repositories that have the code for these agents, we feel like, oh, it's just a LLM with a bunch of tools and is all skill files. So is it the scalable way? So that's basically some research that we were going through in Jaseci and still continuing. So first of all, so the two key challenges is that one thing, prompting. When you want to directly interact with the LLM, you prompt the LLM. Prompt includes your skill.md files. Prompt includes whatever persona you design. Prompts include basically the output format that you want. So everything out there that you want to interact with an LLM with goes into the prompt. And the other thing is agentic architecture. How do you enforce an LLM to go on a specific path to do a specific task? So for an example, I was recently looking at a skill file for like health check, I think. Some health check skill MD file. It has a specific way the LLM should operate, and if it doesn't, it breaks. But it's written in natural language. It doesn't really do the enforcement. It is a natural language contract. The LLM can violate because it's not a deterministic model, so it can go in wrong paths. So how do we solve these problems? So we have an approach. I won't say this is the end to all prompt engineering and agentic architecture, but we have an approach we can improve. But you can say, and you leverage this and even invent using the same abstraction, you can invent new ways to build these agents. Okay. So challenge one, prompt engineering. So for an example, let's say you have this very simple pipe game. This is actually a tutorial that I kind of, yeah, there was a tutorial online by a high schooler, and I just made his code and put LLMs on it. Was the start of my research, to be honest, like 2 years ago. Uh, so let's say you have a bunch of types, and then you want the next level to be generated by the LLM. That means it will define where the position of the player is, where are the enemies, where are the all the walls. How can we use an LLM to generate that? So in order to do that in conventional prompt engineering, you have to go through the process of writing everything in natural language, defining, okay, what's the output type? Because you are using types already in the program, right? So usually when you do well-written object-oriented code, there's going to be a lot of types in your program. And when you talk to LLMs, there are no types. You may define a JSON format, and then you have to map that into the type at the end. Or else you have to be, you are basically using a bunch of dictionaries in your program, which is not a sustainable way to build actual applications. So it does introduce a lot of complexity. That's where the by LLM piece come in. So this is what Jason showed you in the morning. Let's deep dive what this actually does. So what we did was, let's think about the earlier example where you had the get next level function. And instead of writing a big prompt, define the output and do the output parsing and convert to the correct type, let's automate that entire flow and using this key abstraction called by LLM. So this is a language abstraction built into JacHacks in the syntax. So when you do get next level by and you define what the output type is. So here the output type is a level type. So it will be outputting that level type with filled in fields. So that's the contract with this. So it's a typed contract rather than in when you do like actual like prompting. You do when you do prompt engineering, it's a natural language contract. It might deviate from it. The LLM might deviate from it. But in this way, it will generate the correct type. If not, we retry. We keep retrying until we get to the type. So the level by LLM will tell our compiler, okay, there's this function called get next level. Let's write a prompt. And to write the prompt, we need information. So where is the information coming from? It's coming from the code that you already wrote, which has the types. The type information itself, when the LLM sees this type right here, it can reason with the type. Okay, this has a level object, it has a map. The map has walls, enemies, players. Okay, nice. And the player position is a XY coordinate. That is the position type. So the LLM can reason with these names itself, the names, the types, they can reason, LLMs can reason with this. And when we provide this information by basically scraping the code to grab the relevant information. For an example, in this case, the relevant information is the function signature and the output type. And then we generate a prompt including all of that information and do a structured output generation and convert to the correct type. So that's the underlying architecture, or like simplified architecture of BiLLM. So we're gonna go with some hands-on experience. It's actually, if you go to Jaseci Labs, GitHub organization, if you go to the Jaseci repo, you can go to the organization. And under the organization, there's this Agentic AI tutorial. All the code that I'll be running will be in this repo, in this repo. Okay. So first of all, here we are going to talk about 4 different not abstractions, usages of BiLLM. Actually 3 different usages and 1 way to actually leverage the graph structures in Jack for agentic AI development. So the first thing is very simple. How do we write a BiLLM function to generate a bunch of strings? So it's just very simple, where you just say brainstorm ideas, interests, which is a string, skills, another string, and you output a string. So very simple BiLLM call. And we can enhance its information, because if you look at the line itself, it is very abstract. The LLM might not know what kind of brainstorming do you need, what is the context, is it you are brainstorming to build a product at a company, or is it just a hackathon? So that context you can pass through the sim keyword. So this is called semantic enrichment. So you enrich the existing semantics with small lines of text. You don't need the entire thing. You can have a one liner as well. I just made this into multiple lines to fit into the slide. So it's just like, and to make it readable, this can be a one liner, just saying, okay, this thing is that, and call it a day. So when you do that, that goes into the prompt. The cool thing is, here I say sim brainstorm ideas, but you can also just like here you say dot interests and add add a text to each and every parameter if you need to. So it's not just not the function. You can add sim strings to functions, function parameters, types, type fields, and enums. All of those inner places you can add sim strings. We are calling it sim strings, but still not decided of the name. But it's semantic enrichment is the overall like the bigger scope name. Okay, so that's generate. So you can use Byron calls very simply like this. And in the documentation, you can find how to stream outputs. Like it's just another parameter within LLM. You can just say, I think streaming equals true or something, and it will stream as a generator, and you can do a ChatGPT-like interface, build a ChatGPT interface. That's basically how the ChatGPT is built. So you can you can go into the code and or else point the LLM into the code, the repo, and it will find out how to do streaming. Okay, so that's the first very simple thing. The next thing is a bit different. So this is basically extracting information out of. Oh wait, let me just actually run this. Okay, so this is the repo that I was talking about. Give me. Let's see. Okay. Okay, so to set up, you just need to do pip install Jaseci, and that will install everything. There are multiple ways to install. So if you like, go to jaseci.org docs. So there you can find like installation. There are multiple ways. You can just do a curl as well, but that's everyone's going towards okay. Let's install everything using a curl, but it's very risky. But still, that's the market. So, or else you can do a pip install, which is normal install. And you can install individual components. We have JacLang, ByLLM, JacClient, JacScale, JacSuper. There are multiple different plugins. So the core is the language, and ByLLM is actually a plugin that's built that attaches onto the existing core JacLang. Okay, that was a small sidetrack. Okay. Okay, so yeah. There you go. Okay. So this was the function I was like showing you guys. So you have this, and I'm just gonna just do a Jack run. Jack run basically runs your program without a front end. It's like running Python, to be honest. You do Jack. Yeah. Let's do it clear first. Yes. So, oh yeah, there is definitely. Yeah, I think we forgot to talk about it. So yeah, we have the Jack coder and the just Jack. So Jack is the syntax highlighting and type checker. Everything's built in, so it will show errors, syntax errors and stuff. This is the Jack extension, and this is the Jack coder extension, which is the coding agent. Yeah, good question. Oh no, Jack Coder is a standalone like. Wait, where's the Jack Coder? So if I go here, yeah, Jack Coder. I didn't set up the API stuff. So it's the Jack Coder is what Jason was showing in the like opening ceremony, which is basically another Claude code, but it has inherent knowledge about Jack, and it can reason about Jack in a much clearer way. But you can still use any other thing, because what I use is usually, because Jack Code is pretty new, I have not used it much yet. What I use is usually Claude Code, and I have the MCP server Jack installed and running, and it'll just okay, use the Jack MCP server. So yeah,
Yeah. Does it like run in debug code or is it just like a docs?
So this MCP server has, yes, you can search, it can search the docs. So let's just run this. So it can search the docs as well as it can do type checking for you. It can do, it has a validate function which just like tries to compile and see if there are compilation errors. And when you have the MCP server, the uh, the the AI agent can run those as tools and verify that the code that it has written is correct and continue. So that's the MCP server. So so you can see here.
I'm just asking which tools the MCP has. Oh, okay.
Yeah. So the MCP tool has like run jack, validate jack, lint, format, get AST, get graph. You can look at even look at the graph itself. You can look at the graph. You can like get examples and stuff. So it basically has its own like compiler tools that you can use as well as the doc searching tools as well. Cool. So usually when to install MCP server, because some different coding agents have different ways of installing MCP servers. What I do usually is I just copy our MCP server documentation link to just the agent, and it just figures out how to install itself. Yeah, so that's about the Jack coder, and yeah, you have a syntax highlighting through the Jack extension, so you should get that. Okay, so getting back to, wait, yeah. So the first code that we were looking at, which was, that's right here, okay. So this is the code that we were looking at, like brainstorm ideas, interest string. So what I was talking about is you can do like something like sem interest equals something, not this, no. This is like these are like comments, so you can't mutate them in program. So these are like for you to add more context, not to like live add context to the LLM. There are different pathways to do that though. Yeah, so let's just remove this and just run this code right here. My power level 10K is bugging out. Just clean everything. Sorry?
I'm so sorry, but I just lost it.
Oh yeah. So you didn't miss much, I would say. I was just talking about agents and like how they are built and how BioLLM can help. So this is the first way it can help, which is to abstract away prompt engineering. So it can generate the prompt for you and talk to the LLM as long as you have enough context about the tasks in the code. So that's the contract that you have. Instead of like writing a prompt in natural language, if you have good written, like well-written types and well-written semantic annotations like these, you can get the BioLLM to like work well. So that's what we were talking. Okay, so that's basically what we were doing, and so you can like go to this repo just to remind. So this is an existing repo that has all of these code examples. So you can clone this into your like project and let your code to look at it as well. So that's a other project. Go on.
So you were talking about the game, right? Creating a game,
Mhm.
different levels.
Yeah.
So are we like kind of dependent on the BioLLM function to generate the next level? Like say level one, we have given a different format of what exactly. And going on to the next level, it is the beauty of the BioLLM function to call either Anthropic or OpenAI and get the level one.
Yes.
But will it not create a delay in between during
Yes.
runtime?
So you have to be mindful about what you actually want. So if you want a simple function that auto generates like levels, not caring about the level difficulty or like something like that, you can build like for those kind of functions, you don't necessarily need BioLLM. So BioLLM is not there to replace all functions in your code. It's there to therefore places where you really need to have an agentic behavior, you can use BioLLM there. Well, this example, why we use this is we pass in all of the previous levels, the user has played, and that will give the model a context about what is like the progression, like how fast these players finish their levels, and let's create another level which is difficult than the previous ones. So it's context dependent. So for those kind of functions, it's good to use by LLM. So if it's like 1+1=2, like an add function, there's no reason to use by LLM for those kind of functions. So you have to be mindful about where you use them. Yeah.
I mean, because if we are talking in the terms of difficulty or any kind of complex, increasing the complexity of a particular task, it involves a lot of combinations and computations, right? So if a user is, let's consider game as a primary example, if the user is able to solve a particular game in a particular process, there are multiple other ways to solve it.
Yeah.
So how exactly will a bi-LLM function, implementing it in a like as a form of a bi-LLM function, help us remove those complexities?
Sorry again, I didn't get your question.
So, for example, for level 1, a player can just walk straight. For level 2, he has to just take a jump and
Yeah.
So there is one combo of a jump being involved in the entire game. And So to increase the difficulty, we have to increase the complexity of the code.
Yeah.
So
Oh, okay, I see.
how exactly will a bi-LLM increase it?
So, yeah, I'm going to walk through it. Tell me if this is what you're asking. So the LLM is going to generate a code that then generates the next level.
Exactly.
So the thing is, here the LLM does not return code. It returns the level itself from the model. So the model basically fills in the types and pass a JSON output back, and we just parse it, convert to the type. So there's no code that runs when you do like by LLM. It actually talks to the LLM, get the information back. That's all. It's not running any code, because running the code itself, it's a good idea, but raises a lot of. We actually started with that. We told the LLM to generate the type in the format of Python and do execon, and that will like instantiate the object. But that raises a lot of security concerns, so we went for JSON parse.
I see some examples of the case of using bio like organized context and tracks.
Okay, yeah, sure. That's basically we are going to talk through in the workshop. Yeah. Cool. No worries. So yeah, we were in this point, which is simple. So the next, so this is where like we have this brainstorm idea, and you just you can add context about like, okay, what this brainstorm idea should return, and just and it will always like it will know, okay, 3 creative hackathon. And let me run the code and show. So this is the code that we were looking at, and when you do JacHacks step 1. So I have my API key like added onto my environment. So yeah, so here you go. So I just did like brainstorm ideas, and I had this string, and it just returns like 3 like enumerated like stuff out. But let's say what will happen if we just comment this out. So we are not telling it to generate 3. So now it might generate 5. It doesn't know. It does not know how many to generate in like, and what is the context is. So it'll still run, but there you go. So it gives like 10. It doesn't know like what's the context, and you can, so by basically enhancing the context a little bit, saying, okay, it's 3 creative hackathon project ideas, based on the skills, blah blah blah, and yeah. So this can be also written in a way where you can specify a type called. So this is actually the next part, which is the more complex way to use by LLM, is to have types. So when you have types like these, you have a hackathon pitch. It's kind of the same idea, right? So this is a hackathon pitch, like 3 hackathon pitches, but it generates it like strings. But if you do it like types, now you can enforce what is the title, what is the problem, what is the solution, tech stack, the wow factor, and you can basically define what this type, and you can add send strings to each of these fields if you need to. So this code, if I run this is the second extract. So it's just this code, and there's only one send strings to just inform what this function is. I have not added any send strings for these, for the type itself. And when you run this, jack run Step two, check. So I'm printing it like in this format. There you go. So it gives the title, food rescue match, and so on. Like it extracts the output, and you can just like access the output as like pretty like any programming like object. So you can just access each of the fields and get the outputs. So this is the other way of using it. So I have not added an example of what Jason was showing in the morning, which is the enum type. So you can generate an enum type as an output. So if you have, let's say, um, oh yeah, we have an enum. Yeah, sorry. So here we have like difficulty, and you have three enums: beginner, intermediate, advanced, and you can get the hackathon page has a field called difficulty, and it just returns a difficulty enum. So for an example, if I just did instead of yeah, pitch dot difficulty. Oh yeah, so yeah, wait. Oh yeah, here we go. So it shows difficulty intermediate. So it's returning the type itself, and based on upon this enum type, you can do different things if you want to. You can make the LLM take decisions and give you back, okay, what route to take by using this. You can use it as a classifier. You can use it to do decision making and so on. So yeah, so these are like basic use of BiLLM. So it's just an LLM. You try to get an output. It can be a string, it can be a type, it can be an enum type. Okay, okay, we are on the same page. That's cool. That's cool. So this is another example, like personality type. This is an example that we had like a while back. We're still using it. So this code has examples for those use cases, but what about agentic? Agentic AI is not just an input and a output. It is loops. It loops through the tools it has, and it might do like multiple like worker spawn, sub agent spawning. So those kind of like different flows exist in actual agentic AI. Sometimes the LLM itself does decide what flow to take, and in other implementations, they specifically build what the LLM should do. So let's look at these two cases. Yeah, go on, sorry. Yes. So here in this right here, so it is underneath the hood. After so in so the BiLLM extracts the information. It generates the prompt and the JSON schema. That's the output type. It actually uses the light LLM backend, which allows you to connect to any LLM provider that you need. Automatically, it has their own like URLs and stuff, and you just need to put your API key and model name in this manner. Like here, we can say Gemini 2.0 Flash or 2.5 Flash, and that will allow light LLM to detect how to connect to that. You just need an API key. So yeah.
We depend a lot on structured outputs, right, for getting the exact schema as expected. But like in general, LLMs previously had a hard time. Like Gemini 2.0 Flash had a hard time returning structured output properly every single time.
Yeah.
So does that error happen with LLM function too, or is that taken care of?
So under the hood, we have not like built a special. So we have done some specific work with Gemini, I remember, because there was exactly I have seen this issue multiple times, and there was some special handling that we do underneath the hood, like some you need to enable some parameters, disable some parameters. So those kind of things we do handle underneath, but the model itself is still the same. So structured output generation. So yeah, this raises another sub question, which is what if BiLLM actually fails? What if the LLM actually fails to return the correct type? We can enforce as much as we want. If the model is dumb, it's dumb, so it won't return the type. So if that happens, in this case, it can, the way we have built BiLLM is to when you actually hit, okay, the LLM would not give you the correct type, even if you retry, it'll return a type, an exception. So it'll basically error out as any, so you can do a try except, say, you can do a try except if you want to. It just returns an exception. You can look up the exceptions in the our documentation. We have bunch of these like rate limit errors. We have API key not found errors. So you can just use an exception to capture what's actually going on and do any handling that you need to. We don't specify a specific handling ourselves because we kept it up like for the users to define what way they want to handle this. So, like for an example, like if we keep failing on one single model, we can switch to a different model by the user. You can just have like you can here this LLM is not a keyword, it's a just a variable in this use case. So you can say glob GPT-4 equals this, glob GPT-3 equals this. So this is basically a bunch of like global model instances, and you can just switch models on the fly by just on the fly, in the sense you can switch models. Yeah, recently we had this model pool concept. It's also in the references. There's a lot in the references. So model pool is where you have you can define a bunch of models and it will switch upon a strategy that you define. It can be the strategy can be the least cost strategies there, and there's this API rate limiting stuff. And yeah, go on.
So
Sorry.
we can have like multiple bi-LLM functions that calls on different models.
Yes. Yes.
Can you just like is there any way what can you do to understand how this works?
So this is basically documented. If I like to show you the documentation itself, let me just go to. So if you go to full reference and have AI integration, BiLLM reference. So that shows you everything that you can do with BiLLM. Like for an example, it will show you how to configure the models. Oh yeah, there you go. So you can do it in two ways. So previously we can do, you can do it like this. So you can instantiate as like LLM equals this. But when you do like full stack application development, you can do it in the jack.toml, which is basically a configuration file. And you can define multiple LLMs in the config file itself. So without writing it in the code. So we allow both, but you can choose which one to use, which way to use it.
And this skill is also available as the MCP.
Yes. Yeah. Yeah, go on.
So if we want to be comparing outputs from multiple different models, before generating the final output, you want to compare like the intermediate outcomes. Like, is there like a best way to do that?
So when you say compare, so when you compare two outputs, if it's like I feel like it depends on like the output. So so BiLLM doesn't think about correctness in terms of like what's the correct thing. That's up to the LLM. We try to format it to the type, and like with a string, so for a string, so the LLM should be like intelligent enough to understand that. So for the question that how to compare stuff, the approach that we have been taking, yeah, it's been there for a while now, is to actually have a separate better LLM, in a way like a powerful LLM that's like a judge. So it's called LLM as a judge. It's a paper out there as well. If you know Chatbot Arena, that's another place where you compare different LLM outputs. So that's kind of been the approach. Have a separate LLM as a judge to decide which is best. So if it's like yeah, that's basically the
So you're
approach.
just taking the outputs from the two original LLMs that you call these bi-LLM, and you have a third bi-LLM where you feed in the two
Yeah.
outputs.
Exactly. So three BiLLM, basically at least three BiLLM calls. Two to generate the same thing, and another one to evaluate. So yeah.
Sorry, just like one more follow-up question. So, like, if I'm doing a bi-LLM call on the same model
Mhm.
like, twice, am I guaranteed to have like, or am I guaranteed to have the same outcome, or could I have different outcomes? Because like models are inherently probabilistic, so they can produce like different outcomes in different iterations.
So yeah, in this case, if it's like so if the output is a string, that's like an essay, definitely when you call it like two times, you can generate two different outputs. It's not capturing the output and reading the output same all the time. That's a feature that we are currently implementing if you want to catch stuff and like always get the same result. But in on default and in the current implementation, we always call the LLM and get you a new output, and it can be different if it's a like text output. But if it's a structured output that, let's say, you have a bunch of text and you want to extract a person's details out of it, it can be deterministic most of the time. Most of the times, like, outputs the same content. Okay, so the next. So going forward to the next thing in Agentic AI, we're talking about flows, and when we actually look at many of these, sorry, sorry. Yes, it will be shared out like after the this workshop. I'll share it on the Discord itself. Yeah. Cool. So the next thing, pattern. So in LLMs, how they operate, these are not like the complete set of patterns, but there are multiple different patterns that emerge. Like you spawn a bunch of subagents, basically like tool calling, multiple parallel tools, and you do routing. You route to a different task to different agents. You can see this in open code repo where the request comes into a main agent and they decide whether it's build or code search or there's some another agent. So like there was 3 agents in the open code repo itself. So these kind of approaches exist. And how do we build this into the application itself using ByLLM? So that's the idea. So yeah, you can talk to LLM using ByLLM, cool. But how can we actually build agentic features in using ByLLM? So for that, we have inherent, inbuilt native tool calling. So here, what we do is, so you have this function called def research idea, and idea is a string, and output is a string, fine. But as tools, we provide a bunch of tools that you can use. So here we have search GitHub, describe tech stack, estimate build time. Actually, those two describe tech stack and estimate build time are another 2 ByLLM functions. So you can add tools like ByLLM functions to be tools of a bigger like ByLLM function. So you can have that behavior. And here we have a bunch of tools. So these are a bunch of tools that we pass to this research idea. So in the backend, we implement a React loop. If you, React loop, if you have heard about this, it's called Re-act, not the normal like npm React stuff, like JavaScript React stuff. So this is a React loop in the agents where they can reason, act, do something and get the output and reason about that, act again, and it continues on a loop until it gets to the result. So that can be implemented in ByLLM simply as define your tools as a bunch of functions, pass those functions into this tools list. So that's the approach. So this is a LLM with a bunch of an LLM with a bunch of tools. So that's kind of the approach of many applications that we have seen, like open code, OpenClaw. Yeah, OpenClaw has a different architecture, but in a similar way they work. They have an LLM with a bunch of tools, and the LLM decides how to use these tools. And to tell the LLM how to use these tools, there is a specific skill.md files that basically you put onto the context of the LLM and it understands how to use the tools. So here we don't. If you want to do like, I'll show the code to this right now. Step 3. So in this case, if you really want to like add more, like say like a skill.mp file, if you need to, you can do it through incl info. So incl info is a kind of a bypass where you can add anything, any chunk of stuff into the LLM. So, but automatically our ByLLM runtime like extracts what to be put into the prompt, but you can bypass all of that just and put a blob if you need. So you can say incl info equals knowledge and say some. Oh, sorry, this is a you're helpful assistant if you really need to. You can pass in something like this. So you can basically have a skill MD files, load them, and just pass it in. So this will be in the it assures that this will be in the context of the LLM every time. So yeah, I'll just remove this for now. Okay, so let's just run this code. Jack run invoke. I'm just going to grab So this is gonna do research this will like call the tool. So this might take a little bit of time. It is also like implemented that where you can stream using these tool calls as well. It's you can learn how to use the streaming stuff if you need to on the reference in the reference as well as in the Jack GPT repo where it's actually implemented. You can have a look in there. Okay. Oh, wait, did it stop running yet? Yeah, still running. It keeps researching using the tools it has, and it will give the output later. Oh, there you go. So it basically gives you like recommend the tech stack, yada yada. Okay. So it actually returns actual Git links. Like if you click this, it'll go to like actual GitHub repos out there, and it'll like search the web, get GitHub links, and give you those links. And this is step 4. I'll quickly jump to step 4 because we had to wrap things up pretty quickly. So in step 4 is where we use the node structures in the nodes and walkers in our agentic build out. And let me just quickly go through what we have. So this is going to be a bit of let me just slideshow. So in Jack, you have nodes and you can have edges where you can build the graph. And there's another thing called a walker, which can walk the graph when you spawn a walker on a node. That's like it's going to be a lot of stuff to like digest right now. So the best way I would say is just ask LLM questions with the MCP server. It knows how to like code in these patterns. So walkers, you can define how to walk, and you can build like this is how you build a graph in Jack, where you do ++ arrow sign to like an arrow-like sign to add nodes, and whenever you want to visit, you can do like this. And here we can use ByLLM in this context. When you say visit, this returns a list of nodes that are connected to the current node. And when you say ByLLM on that, it will actually decide on which node should I visit and direct the walker to those nodes. So it will not like visit all the nodes. Like the default visit statement is to visit all the connected nodes. But when you say ByLLM, it will visit only the nodes that's required and visit them sequentially, and in the particular order that you need. So for an example, here we say include info like hackathon pitch, like you pass in this pitch into this include ByLLM thing, and it'll get the context of this walker and any nodes that it's gonna touch, and it's going into the context of the LLM, and the LLM decides which nodes to walk. Okay, so I'll just quickly show you the code. So this code is like 100 lines. So you can clone this repo and look at the code yourself. And basically what we have is we have a walker called advice worker, and you have like a web dev mentor, this bunch of nodes called web dev mentor, mobile mentor, AIML mentor. So there are a bunch of mentors. And when you spawn this walker on the root, it will actually connect these nodes to its current node, which is the root in this case. And then it will basically run these the same walker onto these nodes. And whenever they enter those nodes, we can write these functions, which are called abilities. So if you have can respond with hackathon advisor entry. So the hackathon advisor is the walker, and whenever the walker enters, this function runs. So basically these nodes and walkers, how they are constructed is whenever a walker enters a node, you can run a bunch of abilities, and you can write these abilities in this way where you can basically say can respond with hackathon advisor entry. So if any instance of an hackathon advisor visits this node, this function will activate. So it's kind of like event-based triggers that you can place in the graph. So you can learn more with Cloud Code and when you're actually building stuff. And you can use visit by to actually decide, okay, these are like experts, so which expert to visit given the current context, which is like the self pitch. So these are like examples of applications. So to build an entire application out of using all of these agentic systems, I have written a small code with the front end as well. So the front end connection happens here. The front end is like available here. I'll just run it for a demo, and you guys can like deconstruct that code. and either show me better ways to code in the same application, or else you can use these abstractions for your projects. So let me say just start. Oh, my bad. There you go. It's in app.jacks. So when you do jack startups app.jack, it's going to look into this jack.toml. It has all the packages that needs like installing, and installs them and bundles up, and it runs this front end right here. And I'm just gonna say, oh yeah, someone tell me your interest, something that you want to build in the application, in the hackathon. Okay, you don't want, guys want productive? Okay. Let's just add that for now, task management, and let's say Python, Jack, web dev kind of. So it will like, when you do that, you will see that LiteLLM is being called. So LiteLLM is like the backend. If you want to look at the prompt, there is this, you can activate verbose equals true in the, you can just search for verbose in the documentation, you will find where you can enable, like you can print the prompt to the out to the log, so you can see what actually going into the prompt. So oh, there you go. So you have like 3 brainstorm ideas. Let's just pick one. So focus, flick, just put it here. Structured pitch. So it will take in this one like sentence, and it'll give out, okay, this is like the problem, solution, a wow factor, and like what's the tech stack it's going to use. And then you can just research the idea. This is going to take a little bit of time. So it's going to basically, these are the 4 steps that we just ran, but built into the application with the front end. So it's going to call some tools. So this actually, in the code, you can find that I actually added, let me see, in app.jack, I am actually importing, because the Jack MCP is a Python library, so you can just import it and use the tools as just functions, like import and put, like force those tools to be tools for the LLMs. So that's I'm basically like doing that for like the last step. So this is like invoke research, similar no results found. That's strange, maybe. Okay. And you can say get mentor, and it will just route to multiple agents and do some research on it. Go.
I'm still comfortable with the whole the business statement and how it can also that.
Yeah, it is actually, it might take some like deep dive into how to like with the time constraint, I'm not like able to like explain it like deeply, but let me just find a good documentation. Oh yeah, so if you go to let me just go through this real quick. Get started, build your application. Okay, so I think you remember like the root concept Jason was talking about in the morning. So each user has a root, and to the root you can basically, like in this task management application, you can add tasks to this root, and it will again persist to the database. But it also allows you to like write. Let me go to. Yeah, so this is like a kind of a query language to query the graph and fetch like the nodes that you want. You can filter nodes using this query, like Cypher syntax. And let me get to a Walker real quick. Walker. Nope. So okay, there you go. This is kind of it's the same. So these are like early functions that you can use, but instead of functions, you can use walkers, which is what I prefer to write. Let me just should be somewhere. Let's just search instead. There you go. Okay, so that's basically one. Okay, object spatial programming with walkers. So when you have this when you have a root, you can build this graph as, okay, you have this task, 3 tasks, and whenever you have this list task walker, spawn onto the root, you can write code to tell it to walk the graph. When you say, for an example, as a code example, if I say walker at task, so what it'll do is whenever it enters this root node, whenever the walker is on the root node, it will run this function, which is basically you get this category and new task equals here plus plus uh, yeah, using this syntax, you basically add this new task to that root node. So here means like when you are on a walker, when you say here, it means this pointer to what's the current node it's on. And on the node itself, you can say visitor and it will know what's the walker as well. The current walker can be referenced using the visitor keyword. So there's these two keywords here and visitor. So that's why it's actually at the bottom, because it's a bit of a mental, you have to deep dive this to actually understand. So that's why it's kind of at the end of the entire tutorial. So to spawn a walker, you just do root spawn at task. At task is the walker that we just defined. And when you spawn that on the root, it will trigger this function. So it will trigger the function and add the task. And you can provide this, at task has this title field. So you just put the title there and it will add that task to your. So like the example I was showing earlier ago. So add task title buy groceries. So this is like how this walker works, the walker and the ability triggering works. And the other thing about walkers is visit. So when you call visit, what it will do is when you say, okay, let's see this, okay, list tasks. So this is a function that's used to get all of the tasks and return all the list of tasks that's available from root. So what this will do is it will first, when it enters the root, it goes to start. And now I say visit. And what this does is when you say visit and have the syntax, this syntax right here returns all of the nodes that are currently connected to the current, where the walker is. So all the connecting outgoing nodes are returned as a list. And when you say visit a list of nodes, it will visit each of these nodes sequentially. So it will go to the first node, the second node, third node, etc. And when they visit those nodes, so that's the task node, right? So we have these task nodes that are already connected. So we say, okay, at a task node, run this collect function, which is basically self results append here. So self is the list task walker, which has a results list. So it just appends all of the tasks it sees onto a list. And when it's back on the root, and you can see exit, it does everything and come back to the root. That's when it exits the root. So it's like a depth first search. And at the end, it finishes and exits the root. And when it exits that root, we say, okay, report self results. When you say report, this will be basically, so this walker, when you say report, it will actually return a dictionary, like a JSON object. So these can be, when you do the front end, the full stack implementation, these walkers are kind of endpoints. So they just appear as endpoints that you can call, and it will return this like report out back to the API call. So this is how a walker and like the abilities like operate. Yeah, go on.
So exit, it's just run after everything else.
Yeah, it's like a depth first search, and then after everything runs, it comes back onto the same root, right? So you do a depth first search, and you go onto all nodes, and at the end you come back to the finishes with the final node, right?
What if the graph is set up in such a way that like the walker doesn't come back?
Then it will not actually run the exit walkers. Yeah, so it's up to you to actually use. If you like, it's not like if the graph is not built in such a way, what you can do is let's say whenever you finish traversing, let's say you are checking whether you have visited all of the nodes and you exhaust the list. You can like keep a track of all the nodes that you visit and you exhaust the list. You decide let's like finish walking, and at that point you can report too. So you can report anywhere in this like traversal. So you can report back at any point. It depends on the condition that you set. So here we are setting go walk all nodes, and then when you come back, do this. So that's kind of the approach here. So you can use entry and exit into in different ways to build the applications. Basically, anything that can be built in object spatial can be mapped to this graph format, but you don't have to do it every single time. But whatever makes sense to build as a graph, build as a graph. So that's our approach. So this is the object spatial feature in Jack. To be honest, the LLM understands this much better than we try to understand, because with graphs, LLMs can reason with graphs much better in the sense, even when we actually code, we think about it as a graph and build it using objects. It's kind of, yeah, mapping our graph thinking pattern back to the actual objects themselves. So this actually lets you build the same way you think. So that's the approach. And LLMs understand this really well. As with the MCP tool, MCP server, it works really well. It can code object spatial really well. Yeah. Cool. Okay, so yeah, so you have this full stack app as well in the repo, so you can just do jack start app.jack, and you'll just have that program that I was running, and it finished and gives it visited all of these agents, and it just gives what each of them output. So this guy actually shows you the code itself, because it has the tools, so it can actually give you the code as well, because we were passing tools to this Jack expert. So yeah, cool. I think that's what we have for the workshop. And so to finish it up, again, you can find it on Jaseci Labs Agentic AI tutorial. We'll post this on our Discord channel as well after this session. The slide set as well as this links. Yeah, you don't need the hands-on experience. I'll just tell you this. Yeah, you can. Those links are still already on the Discord. So, and if you run into any issue, either ask Claude, and if Claude can't figure it out, just go to Discord, and there's this help channel. You can just ask away there, and they'll help you out. There are people outside of this country actually staying up and trying to help us run this hackathon smoothly. Cool. Okay, any other questions?
Currently, as we do not have Claude ETL codes, will this run on Gemini or any other open source?
So, when you say LLM or the coding? LLM will work with even local models, but it depends on how good the model is.
We have to anyways provide the documentation for the local model to learn what exactly is happening.
Yeah, exactly. So you can just switch the models to Gemini is kind of our go-to model because it's free but very limited. So you can basically catch the rate limit error and do give a small latency and run it again if you want to do that. But yeah, so you can switch to Gemini. You can switch to wait, let me see. So you can switch to, if you go to Light LLM. So if you go to docs, there you go. This is not the docs. Oh, this is the docs. Okay. Proxy, no. Python SDK. Yeah, changing the docs pattern a lot. Let me just search for docs models. Okay, providers. So if you go to providers of Light LLM, it shows OpenAI, Azure OpenAI, Azure AI, Vertex, Google AI, Anthropic, Bedrock. There's a bunch of different providers that you can look through. If it's Olama is a provider, you can just download an Olama model and run it as well in your machine if you want to. But you can go through there are multiple different providers. We're actually working on getting you guys API keys. We're still working on it. I think we'll inform about.
I get the bottleneck situation right now, but for that, until then, we can't proceed. What is the alternative method?
So the best alternative right now is Gemini. You can get a Gemini API key. Other than that, for testing purposes, I've been using an Anthropic key with a $5 top up. But it's up to you guys if you want to go that way, because that will give you access to a good model for up to some time. So yeah, cool. Okay, I think that's basically it for the thing. So thank you guys.